First of all, thank you for the invitation to be this event. So let's start. Okay. So basically, in any discussion about nuclear, you will get this expression better safe than sorry, referring to the precautionary principle. So what I will do here, I will present or discuss the precautionary principle in a nuclear context to explain the current situation of the nuclear industry. Let's start with an example. Let's take Trondheim as a case. Before the electricity in Trondheim is produced using just nuclear, what we need is basically a cube of its size for producing all the electricity for 1 year. This is amazing when we compare it to the amount of coal, 210 million kilograms of coal for doing the same. The problem is that all this coal will be transformed into ashes, CO2, SOx, NOx, and then dumped into the environment, producing more or less around 20,000 deaths per year here in Jordan. So, but we will get a lot of groups saying that nuclear is a problem because the tiny amount of radiation is legal. Okay? So let's go to the origin of this problem. Let's go to back more or less 4 billion of years in time. So basically, one of the recent theories about the origin of life says that the origin is related to the nuclear power plants, natural nuclear power plants that produce basically heat, move the water, with the radiation coupled with the chemistry. This nuclear reactor was postulated in the 40s and then was discovered in 72 in Gabon, in Africa. These reactors will provide also the proof for the long-term safety value in waste disposals. However, as you can see, these people are sitting just in the middle of the reservoir. Okay? However, the precautionary principle will say it is better to be safe, banning the geological repository than be sorry that someone, by chance, make a hole of 2 kilometers precipitation in target material, making it smooth and shrinking, saying that the small amount of radiation is limited. Okay. So, but why? Basically, life evolved in a fairly radioactive and chemical levels. This implies that life need to cope with this, and this was done by adding mechanisms that can allow the cells to fix errors, basically detect it and fix it. If something goes wrong, the system can basically send signals and kill the cell. And if it's not working, basically you send my body to cancel the cell or to other disease. In 1979, was discovered that the responsible of orchestrating this mechanism is the protein P53. Remember, 1979. Okay. Then in the Nobel Prize of 2015, it is related to the mechanism that are fixing the DNA. But now the damage is not related to accidents. Every day now here we are suffering with more than 10,000 single-strand breaks per cell per day, and more than 10 double-strand breaks per cell per day. And all these are being fixed all the time. Repair and fix. Okay, so if we receive a dosage of 100 millisieverts, basically what we are doing is adding 100 breaks in the first case, 4 breaks in the second case, and this can be fixed. For reference, if you eat a banana, that is 0.1 millisievert. If you take an X-ray, it's 2 millisievert. Living in Norway, 5 millisievert per year. Living in Ramazan with 260 millisievert per year. Okay, but remember, Chernobyl, and due to the precautionary principle, basically 300,000 persons have been moved, forced moved, because they receive an extra dosage of 5 millisievert per year. Okay, so even though people have been going to hot springs around the world for centuries for the therapeutic properties. One of these is Nissan Osen in Japan. That is one of the most radioactive hot springs in the world. Yeah, in the 50s, was found that the people living there have expressed low cancer rates and better health. And then studies in the 2005 identified that the people there are overexpressing P53. Remember, it's the protein that helps to keep the machine working well. Okay. Today, we know that the low dosage radiation can have effect in boosting our immunological response. It's also considered like a potential treatment for Alzheimer and dementia. However, the precautionary principle have been limiting this kind of research and studies. Okay, so let's get back. So we have nuclear power with all these advantages. We have now know that the radiation might be playing an important role in flight, the reason that effects here. Our cell has a role in a highly radioactive environment, and we are a consequence of that. Cells and DNA are self-repairing mechanisms for fighting and fixing the damage, and low dose of radiation can be beneficial. But the tiniest amount of radiation is little. Okay? So in order to understand this, we need to go back in time. So now we are going to the end of the 1890s and the discovery of X-rays and radiation. That will trigger what's called the X-ray mania, followed by the radio mania era. Okay? In this period, everything will be X-ray. And this will be followed by the fascination of the society with radiation, atoms, and radioactivity. In this kind of context, the anti-nuclear home testing movement will start to emerge. Okay? And they will have a problem, they will have a challenge. They need to go against the view of society against the atoms. In order to succeed, they need to try to change this view. Okay? Let's move on. So now, at the end of the 40s and 50s, when working with radiation, it was common to use limits or thresholds for defining your working. This will change. Basically, you have Herman Miller will do experiment with flies with high levels of radiation above everything that you can imagine. They will get some experiment in this point, and then he will decide to take a line going to zero. Okay? This is called the linear no-threshold theory. And then he will postulate that every dose of radiation down to a single gamma ray is a threat to the genetic heritage. This is basically what we are getting. The tiniest amount of radiation is. Okay? But everything around us is radioactive. So basically, bananas, carrot, and ourselves, according to the precautionary principle, is better dissolved. Those bananas, don't fries, don't hug your friends. That is orange. Okay? Then here is the other place that I explained in green, represent that low dosage radiation can be beneficial. Okay? Now, how we interpret the linear non-threshold theory? Basically, if we have 100 persons around, basically 30% of these will die of cancer, some claim cancer. Okay? So now, if we are exposed to 200 millisieverts, this implies that one person extra will be dying for radiation. But remember, this is according to the model. Yeah. But remember, if you are living in France, you are getting 260 millisieverts per year. But the problem is very complicated because, first of all, we cannot differentiate the causes of cancer. It's not possible to get a biomarker. Second, as you can see, the relative risk of cancer in this range of doses is similar to the risk of cancer related to smoking, drinking, not eating your veggies, eating too much salt, and so on. And this is the reason why it's so difficult to agree in this case. Let's move on. So now, by the 56 committee, we take basically the LMT theory, and we replace the threshold theory that was used up to this moment, related to Manhattan Project and all the activity related to nuclear. Then this committee, or following this committee, will get a kind of important cover in the media, getting all this kind of announcement, triggering what was called the radio mania era. So we changed from the radiophobia era. We changed from the radio mania era to the radiophobia era in this process. Now, another committee in 1974 will introduce another concept that is basically as low as reasonable achievables. Okay? So the effect of this concept is basically make nuclear power as expensive as possible. The main idea is that Sequoia power plant was just in the middle of this process. Before Alana, the power plant was costing $3 $100 million, taking 5-year construction, normal in this time. After Alara, this cost 5 times more and 12-year construction time. Good. Now, in this period, what we have, the anti-nuclear bomb testing will change to anti-nuclear anything. And with this process, we'll start to introduce new symbols. One is nuclear destructive. Frankenstein, nuclear science will be basically the modern Frankenstein. And then we will get the elements from some activists like Gunther Anders that will say every nuclear power plant is a bomb. We are fighting the nuclear itself. He will also be introducing some elements that will be using the normal anti-nuclear movements. That is the concept of the Prometheus gap and the Prometheus check. Okay? So some of the anti-nuclear groups will merge with the environmental groups that will evolve into the dark green movement that will start with the called monkey wrench operations. Okay? So Gunther Anders said that in the case of an state of emergency, like having these nuclear things around, then we'll justify the violent self-defense. And as a consequence of this, we'll be evolving into a very complicated period of time where basically this thinking will start to go into what is happening today in the nuclear industry. So here you can see some of the examples of the violent self-defense, bombs, more bombs, sabotages. So this was how to be working in the nuclear industry in this field. So now, 74. Basically, what we have is the German movement managed to change the law and introduce 3 main words to take precautions. This will change everything. This is introduction to the precautionary principle that will be key legal element for the phasing out of the nuclear industry in Germany. From the 80s, Norway will take the same element and will introduce in different legislation. Okay, we can have nuclear power in Norway, yes, but it would be very difficult or even impossible to fulfill the requirement of this new legislation. The precautionary principle is used in many legislation around the world, but the question is how it is used. The regulation basically define the limits, and the limits define the cost. So this implies that a nuclear power plant in Norway would be way too expensive, according to this regulation. Okay, so in the same period, now we will have a lot of accidents in the energy industry. One of these is the largest single energy disaster, costing 25,000 deaths, followed by 200 more after the accident. This is the accident of the Vankiao Dam collapse in 1975. They will be followed by the most publicized industrial accident that is Chernobyl. This will cause 31% death as a consequence of the accident. 15 will die of thyroid cancer. 6,000 will be diagnostic cancer and flu. But the most serious part is that you will be getting more than 200,000 abortions in Ukraine, Belarus, and Russia. You will get around 50 abortions in the first 6 months in Italy, the same in Greece, and 300 persons will be removed just as a consequence of the precautionary principle rather follow at LNT. Okay, so this set basically the end of what we call the first nuclear era that is characterized by radiophobia, LNT, ALARA, precautionary principle, and the nuclear regulations, and being affected by blocking the nuclear deployment in the 80s. The second nuclear era is coming basically in the 2000s, and we have several problems. One is that we need to review LNT ALARA precautionary principle. It's an old concept, science must change. And second one is the bias in evaluating nuclear with everything else. Okay, so here in blue we can see the fuel for 50 years of operation in a nuclear power plant. In red is what is left after the beatification of the radioactive waste. All this one will be sitting around here. So it's not much. We have external regulation, tracking, and follow-up. In order to compare with the magnitude of the sites, we can see very little. But the main problem is that what is the result of not using nuclear. So all this amount of material will be just sent to the environment. We live there forever. We affect all future generations, and the precautionary principle is not even mentioned. So the main problem is that the precautionary principle cannot only be used with nuclear. And with this, I conclude. Thank you very much.
Thank you, Carlos, for this very dynamic presentation. We look forward to discussing it with you. But for now, I will move straight to my presentation. Yes. So I presented a professor at the Department of Philosophy and Religious Studies at NTNU. She's also director of NTNU's program for Applied Ethics, core partner of NTNU Sustainability, and member of the government-appointed Nuclear Power Committee in Norway, among other things. So, Mike, we're looking forward to hearing your thoughts.
Thank you. So, where do I find my presentation? Yeah. So, I'm impressed by the presentation by you with so many slides. I have only very few slides, but I think that is actually also something that suits my presentation because it's more on ethical reflection. And I think so. So maybe let's just. I think actually, you also touched upon some of the issues that really relate to ethical issues. So I hope we can get to some interesting discussion on that. I wanted to start to say something about facts and values, about questions to be asked. Because I think everyone in the audience, everyone here knows that there is not it's a very complex technology and very yes, doesn't it work? Okay. Oh, no. Yeah, it's no. I it was really low. Okay, so yeah. So I think hopefully we will find some links between our two very different presentations. And I'm also happy that you brought on board some of the ethical issues and in particular the precautionary principle, which is used and misused. And it depends when you can use it. I think that's actually indirectly, more than indirectly, something that you asked as well. But so what I want to start out with is facts and values, questions to be asked, because there are a lot of facts, a lot of contested facts, and there are very many values, and there are contested views on this one. How should we, in the first one, start off with? Why do we need nuclear power? Why do we need to have that in Norway? And that brings us to question, how should we justify increased energy demand in Norway? That's the first thing. I know, as a matter of fact, we know that industry, a lot of people want to have more energy, which is good for very many reasons when compared to other sources of energy. But that's so I just raised the questions now. And one thing I would like to ask is whether it's likely that nuclear power plants will reduce negative effects on climate change, because that's one of the beliefs that many people have, that it will, and we all know, and I want to have this debate nuance because it's not an either or. There are certain things that we definitely should solve by nuclear, but it's also a question whether we will reduce negative effects, which has to do with consumption. If you compare 80 cars, for instance, think of technology that facilitates a lot of things for us and also become more energy efficient. But the result is to look at what happens. Well, what very often happens is that then we can consume more. So there is something called the effect in Norwegian. So and this is a dilemma, and to try to solve it by technology. Of course, we need to do that. So I'm not holding that we shouldn't develop technology, but there is a problem that there comes something with. So do we need further nuclear power to reduce damage to nature? We can compare, as we do in the lively debate these days. We definitely discuss some of those sources we thought are key sources, like wind. The sources we can compare nuclear to. Also pose a lot of problems when it comes to questions about damage to nature. And maybe one very serious concern I have, at least, and many more in me, who controls technology development. These days, we know that tech oligarchs, rather than democratic processes, are the government process. And then, lastly here, is it possible to prevent new technology from being used in the service of evil? And you also touched upon this here. So let's just move on. We all know about dual use. And for people who manage the technology, we know that most of the atom fission is what we discuss these days. Maybe fusion in the future, but as for now, it's fission and this technology of releasing energy can, of course, be used for producing energy for the good or for the bad. And many people in the debate call that like for civil use or for production of energy is a completely different story than for producing it for weapons. But we also know that it's not that difficult if you really want to use it. So different. So let me just turn to the risks there. I think that we all know that there are risks related directly to the technology itself, but there is no such thing as technology in itself. Technology is always embedded in some particular context. So, and one concern I would like to raise here is the decision makers and general public that are exposed to insufficient knowledge basis and victims to a biased debate. And we know that all sides in this debate will hold this against the others in the debate. But I think, as a matter of fact, we have a quite biased debate having to do with people not being sufficiently informed to make good decisions. And I think that has nothing with directly with technology to do, but it has it becomes more serious the more language which is possible, because scientific controversies, we know we have a lot of them in the nuclear area, about costs concerning technology and energy power system. That's no unison. That's no people are divided in also about questions about costs. And it depends on who is going to pay us, but we can't go into the details. Environmental impact. And then we have the 3 S's. I don't know if the audience here, if you know about those 3 S's that are mentioned in the nuclear area. That's safety, security, and safeguards. Is that something you're familiar with? Not particularly, because this is something which is finding really important when discussing risk in the nuclear area. Safety has to do with to prevent accidents. That's so this is terminology. That's to prevent accidents. While security has to do with to protect from threats of unauthorized people having unauthorized access. So that's a different story. And safeguards, that's actually to verify and deter misuse of materials. And this is what this International Agency of Atomic Agency, what is it? Atomic, IAER. Yeah. Accidents, sabotage, materials. So this is an agency who oversees and try to prevent this from happening. So we have international agreements on and this is actually the transition from using nuclear for good purposes and just going into something which is damage on purpose. And of course, the third main thing worry these days is where do we get the uranium and where do we get the thorium and where do we get the materials from? And in some of the geopolitical situations has to do with power balance, dependence, independence. We even if we have the materials, and we believe we will have for a long time, and but maybe we don't want to cooperate with those who wasting the work. I don't want to do this very much time. Some minutes. Okay. So, and I wanted to try to say something about why the precautionary principle is difficult to apply when it comes to nuclear. If we think about this as a situation, we have to make decision under uncertainty, and just thinking about what kind of uncertainties are there. Who will we be dependent on? How will people with bad intentions use the technology? A lot of these uncertainties we don't know. But there is especially one thing I think is quite important to think about. How will this be received in a Norwegian context? And that is go directly to the question, will it be a good idea to have nuclear SMSs, small, modular reactors in Norway? And that's a big debate these days. And there are lots of arguments. I don't want to get into those right now. But there is a belief that there is something we think would be a good thing for Norway. But the thing is, if we compare nuclear to other kind of energy sources, we also know that people's opinions have changed. When we think of windmills, for instance, that's a very typical case to mention. And decision on this uncertainty, the degree of dependence on foreign competence. We don't know much about this in political unstable times. And there is a lot of principles, but one principle is, should we choose what will cause less damage if the worst thing happens? And maybe that's could be said that we have got missing on a lot of opportunities because we acted according to such principle. For this, we don't need. Precautionary principle, how should we apply it in a situation of uncertainty? I'm not so sure. So this is my last slide, which is make a little bit of sense. The Coleridge dilemma, which actually don't, it's not a dilemma that applies only to nuclear, but to all kind of energy, all kind of technology, new technology. So it's an information dilemma, and it's because it's difficult to predict how a technology will work before it is developed. Just think about the mobile phone. No one knew before. even if it's not causing maybe not so much damage. But anyway, uncertainty, and then that's the power and control aspect. It is difficult to change when the technology is established. And this holds, of course, for all kinds of technologies. But it is particularly important, I think, in the debate on nuclear, because if the worst thing happens, and if we cannot control what's happening, it's probably in a category which is much worse compared to windmills and other sources of energy, even if those also cause damage. So uncertainty and nuclear power technology. Improved nuclear technology does not solve the coverage dilemma. This stage cannot predict social and political consequences of technology implementation. And the last thing I would like to say is that even if we know it works well in some societies, we do not know how it will work in a different context. So the importance of the context is something I would have liked to discuss in details, but we don't have it. So thank you.